Okay, in the previous lectures, we looked at inference about a population mean, and now we're going to look at inference about a population proportion. So in this summary on the slide, if we look at the assumptions, we have to work with large sample sizes so that we can make use of the central limit theorem. And then you see the test statistic, and it follows the approximate standard normal distribution, and that is again because of the central limit theorem. And because it follows the normal distribution, we find the critical values for our rejection region. We find that also from the Z tables or the standard normal tables. So let's have a look at an example. The manager of a large shopping mall claims that 65% of shoppers favor longer shopping hours. A random sample of 300 shoppers in the mall is selected, and 182 are found to favor longer shopping hours. Is this sufficient evidence to confirm the manager's claim? Perform an appropriate hypothesis test at a 5% level of significance. Okay, so again, you know the steps for hypothesis testing. The first step is to state our null and our alternative hypothesis. So now our hypothesis is in terms of P, the population proportion, and no longer in terms of mu. So that's the first thing. And we are testing the null hypothesis that the population proportion is equal to 65% or 0.65. If you read through this example, you will see that there is no indication that we are testing to a specific site. There are no indications that we want to test that the proportion of shoppers that prefer longer shopping hours is less than 65%, or that the proportion of shoppers that prefer longer shopping hours is more than 65%. So because there are no specific indications to the left or to the right, our alternative is the two-sided alternative. Then in step 2, again, our level of significance is given here as 5%. In step 3, we calculate our test statistic value by substituting the sample information into our formula. So first of all, we want to find the sample proportion, which we call P hat. And that will be the 182 shoppers found in favor of the longest shopping hours divided by the total number of shoppers selected. So that's 182 over 300 to give us a sample proportion of 0.607. And now we substitute it into our formula for the test statistic. So P hat is the one that we calculated from our sample data, that's 0.607, and we subtract from that P0. P0 is the values specified under the null hypothesis, so that's the 0.65, and we divide it by P0, 0.65, times 1 minus 0.65 divided by n, our sample size, and the square root of that, and we get an observed test statistic value of minus 1.561. Now in step 4, we want to find the rejection region. We are testing the two-sided alternative. So our rejection region will lie to the left and to the right. Now this area here in the middle should be 0.95, and the area to the left and to the right should add up to 0.05. So the area to the left must be 0.025, that is 0.05 divided by 2. And this area here should also be 0.025. So we want to find the critical Z value, Z 0.025. So we want to find Z 0.025, and that is equal to 1.96. And of course, because the normal distribution is symmetrical, the critical value to the left will just be minus 1.96. So the red areas will be my rejection region, and the blue area will be my acceptance region. Okay, and now in step 3, we calculated our observed test statistic value, which was minus 1.561. If I quickly make my graph here again, so minus 1.96 over here and 1.96 to the right. My minus 1.561, the calculated one, is around about here, minus 1.561. So it falls, this is the rejection regions, and the blue area is the acceptance region. So this minus 1.561 falls in the acceptance region, and therefore we do not reject the null hypothesis. And then we come to our conclusion. We say that there is not enough evidence at the 5% level of significance to reject the claim of the manager that 65% of shoppers prefer longer shopping hours. So we can redo this from steps 4 onwards for the p-value method. So for the p-value, we calculate the probability that z is less than minus 1.561. So this is my normal distribution. My observed tested statistic value is minus 1.561. My p-value will be the area to the left of this observed test statistic value. And because our alternative is two-sided, we will take this green area and we will multiply that by 2. And as I said, that is because our alternative hypothesis is a two-sided alternative. Now, the area, this green area, you can calculate that using software or even statistical tables. That area to the left of minus 1.561, the green area, is 0.059262. And now we multiply it by 2 because it's a two-sided alternative, and we get 0.118524, and this is now our p-value. So we compare our p-value to our alpha value, our level of significance, which is 0.05. Because it exceeds that, it's more than 0.05, we do not reject the null hypothesis. And our conclusion is the same as for the rejection region method. We say that there is not enough evidence at the 5% level of significance to reject the claim of the manager that 65% of shoppers prefer longer shopping hours. We can do this in Excel again to find our critical value and our p-value. So let's quickly do that in Excel. Okay, first of all, to get our critical value, from the previous lecture, you will know that we make use of this norm.s.inverse function, and the probability to the left of my critical value, you can put in 0.975. That will give you the critical value on the right, or if you put in 0.025, it will give you the critical value to the left. So that gives you your 1.96, or if you want to get your critical value on the left, that will then be 0.025, and that just gives you the negative minus 1.96. Because the normal distribution is symmetrical, if you have the one, then you actually also have the other one. And then to find your p-value, we make use of the function, this function here. Our z value, our first argument there, is the calculated test statistic value, which is minus 1.561. And we want it to be cumulative because we want to find the area to its left like I've illustrated on the slide. So we can type in true, or you can just type in the value 1 for true, and we get 0.059. And to get the p-value, remember, because it's a two-sided alternative, we will just multiply this by 2, and that is our p-value. And there you can also see that we have exactly the same p-value here on the slide.